My name is Terrence Barkin. I'm the Executive Director of the Graphene Council, and we're hosting today's webinar series on graphene and energy storage devices, including batteries and supercapacitors and all those different chemistries that are working on in this sector. I want to invite our opening speaker, Dr. Alistair Davidson from the Consortium for Battery Innovation, to kick us off today. So Alistair, it's all yours. We're eager to hear what you have to say.
Thank you very much, Terence. And first of all, let me say thank you very much for the invitation to speak to you all at this seminar. So what I'd like to talk today is about lead batteries, particularly opportunities for lead batteries in energy storage applications. You hear a lot, as you've already mentioned, about lithium-ion battery technologies, but lead batteries still play a very important role in many markets, and there's a huge potential for this technology in energy storage applications. Before I start, I'd like to just give a bit of background on who the Consortium for Battery Innovation are, or CBI. We are a pre-competitive research consortium dedicated to improving lead battery performance. We are technology agnostic. We think there's a role for all technologies, but we focus our work on looking at lead batteries, but often in combination with other technologies. We have a very large membership, currently over 110 members all over the globe, a big focus in North America and Europe, but we are seeing an increasing number in Asia, and we do have a number down in Australia. Our membership represents the whole supply chain associated with lead battery manufacturer, from lead producers, suppliers like carbon and graphite suppliers, all the way through to end users such as car companies and energy storage customers. And this shows some of our members. We have a number of carbon, graphite, graphene manufacturers. You can see there we have Cellon Graphene, who are a member, as a Black Diamond, as a Cabot, and I'm going to mention it in a moment, but carbon is particularly important to lead batteries. We've seen a significant improvement in performance in lead batteries over the last 10, 15 years, and a lot of that has been down to the use of carbon in lead batteries. And you can see we have a number of partners. We're working more closely with automotive companies, which has been a focus of our work in the past, but we're getting more and more involved in energy storage. Now, we have 4 pillars of work at CBI. Research is very important. So funding work that makes a difference, a tangible benefit to lead battery performance, but really driven by market requirements. And that's what I'm going to talk about today, is what are the requirements for energy storage and how do we deliver batteries that meet those end user requirements. We do a lot of work, however, in communicating and marketing lead batteries. A lot of people don't think about lead batteries as a technology of the future, perhaps didn't see it as a historical use, whereas in fact there's a lot of innovation, a lot of research, and there's a very important role for lead batteries in helping governments around the world meet decarbonisation and electrification targets in the future. But what I'm going to talk about today mostly is research, and with a focus on energy storage. Now, I wanted to highlight about lead batteries for some of you who may be not aware of this technology. Lead batteries have been around for over 100 years. To start with, the major market has been automotive. They're currently used in virtually every vehicle on the road. Your combustion engine will have a lead battery, a 12-volt lead battery that will start your car, power the safety and electronic features, all the way through. It's very widely used in microhybrids, where lead batteries have really improved their performance. They can store energy from braking, which is called regenerative braking, which delivers significant CO2 benefits. So they're very important for start-stop and microhybrid applications. But one thing many people are not aware of is that they're used in virtually every electric vehicle. An EV will have a large propulsion battery, typically lithium-ion. But if that lithium-ion battery were to fail, lead battery takes over, powers safety features like braking and steering so the car can pull over safely. But at the moment, virtually every electric vehicle also uses lead batteries. They're widely used in motive power applications like forklift trucks. They're used as industrial and backup, so backup to cell phone networks, 4G, 5G, backup for hospitals. They are very widely used. But energy storage is really a new market and a new opportunity for the lead battery industry. Before I go into that in more detail, I wanted to highlight the role of carbon and how that links to improving lead battery performance, because as I said, it really is very important to the future of lead batteries and one of the reasons why we've seen such a performance leap in lead batteries over the past years. Carbon has really shown to be a key additive in improving a range of battery performances. So I talked earlier about the use of lead batteries in microhybrid. For those applications, you need to be able to store that energy from breaking. And we've shown that using carbon can improve the ability of a battery to store energy from breaking, which is called dynamic charge acceptance. And that is really critical for lead batteries continuing to be used in automotive applications now and in the future. We've also seen that carbon can improve the ability of lead batteries to accept charge from wind and solar, which can be quite intermittent. And the ability you can add carbon, which improves lead batteries application performance for those applications. We also see that carbon additives such as carbon nanotubes have been shown to help with formation and corrosion along the grid of the lead batteries. Carbon black additives have also been tailored to show how we can promote both service life and cycle life for all lead batteries. And we've also been looking at graphites, and they've been shown to be beneficial for capacity and formation. And that's why we have so many carbon manufacturers and producers involved in the work of CBI, because I certainly believe that the future of the lead battery is very much reliant on using these materials. Now, we've just launched a new technical roadmap. This is available on our website, batteryinnovation.org. If you're interested in any of our work, I would encourage you to go and visit our website, and you can download all of this material. What we've done with the technical roadmap is look at where markets for batteries are going in the future, what are the technical requirements, and then we've set specific goals and targets for research. We've set goals and targets for all types of applications for lead batteries. So automotive for the use in start, stop, and microhybrid, use in electric vehicles, industrial applications, motive power. E-bikes is also something that we believe is a big opportunity for lead batteries. But relevant today, we've been looking at energy storage systems. So we've been looking at where the markets are going, what are the requirements, and how can we deliver lead batteries that can help meet the end user system requirements. So I wanted to show some market predictions for energy storage to start things off. I think it's pretty clear, and all forecasters would agree, that the energy storage market is set to grow substantially in the coming years. And that is very much driven by very ambitious goals and targets being set around the world by governments for electrification and decarbonisation. And batteries are going to be vital in delivering on those goals. However, these goals are so ambitious that we need as many batteries as we can to meet the demand. It's very important that we have as many batteries as possible to meet that demand. One technology cannot meet the demand alone. Lithium-ion will be a very key player, but the scale-up would not be possible in the timeframes needed by these governments. And that means even if lithium-ion were to take half of this market, say in 2025, 2030, there's a huge opportunity for other technologies if they can meet the requirements and they can do it on a mass market scale. And that's something that lead batteries has very much in favor, that we've already at a huge scale. We still represent more than 65% of the rechargeable battery market. We are the dominant technology still, and we have that scale-up capability. But the question is, can lead batteries meet the technical requirements in energy storage? I just wanted to show another highlight of power demands as in the future, and I think it's a clear indication that market is going to continue to grow. I apologise to see there's no years on that. This is out till 2040. Continuing growth in these markets. And so what we've done is we've had a dig down into these applications and looking at what they need. So looking at different types of regulation in terms of energy storage, wind, solar, transmission and distribution, looking at arbitrage, looking at black start, backup, investment deferral. What do they need in terms of power rate, response time, storage capacity, charge acceptance? What are they looking for in terms of cycle life, and energy density? And then based on that, we've looked at different technologies. So obviously lead batteries, but we've also looked at nickel, lithium, sodium, and flow batteries to see how they stack up in these applications. I appreciate this is quite a detailed slide, but really the take-home message is that no one technology fits all the segments, but there's multiple technologies that can meet many of the technical requirements. And I think it's clear that you need all of these technologies in order to meet that demand. And what we've taken away from that is that lead batteries do meet an awful lot of these requirements, And if we can improve in one or two areas, we have a significant opportunity to take a big portion of that energy storage market in the future. So based on this, we've set goals and targets for energy storage in terms of batteries. So we're looking to improve the service life of lead batteries out to 15 to 20 years. We're looking to improve the cycle life to 5,000 to 6,000 cycles. Cost is obviously very important for both low rate and high rate charge acceptance. Looking to reduce that overall cost, as you can see there, down to less than 4 cents a kilowatt hour in terms of energy throughput. We're also looking at things like round trip efficiency, acquisition cost, and energy density. But I think the take-home message that we believe is that we need to improve cycle life and calendar life, improve our round trip efficiency while reducing the cost. And if we can do that, we have a huge opportunity in this market. So the way that CBI works, we set these goals and then we look for projects that can deliver on these goals. And we have a technical program that's currently running, working with battery companies, working with end users, working with carbon producers. You can see there, Cabot, they produce carbon black. We're working with them very closely, developing these projects, looking to deliver on them. See, with UCLA, we're looking at the dynamics of carbon to understand how carbon can improve battery performance. What I would say is, I'm not going to go into detail of these specific projects, but if you would like any more information on these, either go to our website, batteryinnovation.org, or contact me directly and I can explain these projects and how companies can get involved with the work of CBI. But I wanted to pull out some key messages in terms of how carbon is being shown to optimize the performance of lead batteries. So there are a number of different types of lead batteries. What we would refer to as an SLI battery, which is your typical battery which start a combustion engine. We have AGM and EFB batteries, which are advanced batteries that are used in microhybrid and more energy storage applications. And then next generation batteries, such as bipolar batteries, which have even technology of the future. We see really exciting research being conducted, especially in terms of bipolar batteries, and they have significant improvements in terms of performance, but also lower weight and increased energy density. And all these batteries use carbon. So our research is showing that for AGM and EFB batteries, we're working with Ford Motor Company to look at how we can demonstrate. We know that there's real benefit from carbon, but we're working to develop new tests that can demonstrate this. And this work is really important for lead batteries being used in vehicles in the future and lead batteries utilizing carbon. We're also doing a lot of work with the Fraunhofer Institute and a Polish university, WST, looking at how carbon functional groups can impact their ability to work in microhybrid and energy storage applications. And we're working with the University of California to look at the fundamental processes, trying to understand the surface effects of utilizing carbon, understanding the mechanism of why carbon is so important so that we can tailor it in the future. I think for your traditional SLI battery, carbon has been shown to really improve performance across the board for all application. And it is really, as I said, it's the performance of a basic battery to something much more impressive. And it's one of the reasons why we see that lead batteries are still such an important chemistry. And the other area is next generation batteries. I talked about bipolar batteries being very important for all applications, including energy storage. And in these applications, carbon is being used as either the electrode material or as an additive. And it's really paying a lot of dividends in the research that we are undertaking. And I think what I would really stress here is that if companies are interested in knowing more about carbon and lead batteries, all major lead battery companies all across the world, all of them that are involved in R&D, all of them look and conduct research on how to utilize carbon monoxide, graphene, graphite into their lead battery. So there's a big market segment there with the use of carbon in lead batteries. Before I finish, I wanted to highlight a few other areas that we're undertaking in terms of promoting lead batteries for energy storage outside of our research. When you hear some people talking about energy storage, if you ask people about energy storage and the use of batteries, most people think about lithium ion. And as I say, it's a fantastic technology and it has a big future in these applications, in electric vehicles and a lot of other market segments. But there are a lot of projects underway using lead batteries. And we have an interactive map on our website which gives examples of projects worldwide utilizing lead batteries in a variety of applications: frequency regulation, microgrids, peak loading, peak shaving, tariff management. And if you go onto our website, you can look at these projects, and we have a lot more information. We have technical case studies on all of the projects where we explain the size of the system, why they're being used. And in some cases, we have educational videos explaining about their importance and why lead batteries have been selected in these applications. Another thing I wanted to highlight is that on our website, we also have an online tool called CBI Battery Match. As I said, we know a lot of the end users in energy storage perhaps don't think about lead batteries when they're first thinking about battery technology. So we've developed a methodology or a tool where if you're a system provider or an energy user or a utility company, you can log onto our website. You can put information about the system you want to develop, so your power rating, your discharge time, cycle life, operating days, project life, project cost. And then our tool, using an algorithm that we've developed with our member, will identify the best lead battery for your system and put you in touch with customers or battery manufacturers that can provide those batteries. And we found this to be very useful for bringing lead battery companies together with energy storage companies. And we're already seeing a number of projects worldwide being launched off the back of the CBI Battery Match. So if you are interested in that, I would encourage you to go to our website and access this tool. So I hope I've given you a flavor of the opportunities generally for batteries and energy storage. I think there's a huge opportunity for all battery technology and energy storage. The market is going to be substantial in the future, and it's very important that we have a whole suite of battery technologies at our disposal in order to deliver on those future electrification and decarbonisation goals. But there's a huge opportunity for lead batteries in these applications. We can meet many of the end user requirements at the moment, and through research and innovation, we're consistently innovating and delivering batteries that provide more and more performance enhancement. We have the added benefit of being able to have scale up and we can meet the requirements on a mass market scale. So it's a huge opportunity for lead batteries in the future. What I would say is, if you're interested in the work of the Consortium for Battery Innovation, please contact me using my email below. Visit our website, batteryinnovation.org, or do follow us. We have an active presence both on Twitter and on LinkedIn. So with that, I'd like to again thank the organisers for the opportunity to speak together and ask whether there's any questions for me. Thank you very much.
Alistair, thank you very much. This is Terrence. I really appreciate that. Let me pull in my colleagues here. I'd like to invite Dexter Johnson, who's our chief analyst with the Graphene Council. Dexter happens to be based in Madrid, Spain. I'm in the US. So thank you for the presentation. I think there were a couple of takeaways that I took from your presentation. First of all, appreciate the work that your institution has done to kind of, forecast the power demand in the different sectors and the really granular breakdown of the markets. I think that's quite interesting and helpful for everybody. And to really put into perspective, not everything is lithium ion, right? That lead acid, lead batteries have an important role to play. And it was an interesting reminder that even EVs have lead batteries for important power applications. One of the questions, and I'm sure you're not surprised to hear this, question was about the material itself, and obviously with lead.
Yep.
The question comes from one of our participants. I'm aware of the lead battery and energy applications over the last more than 6 to 7 decades, but what about its carbon footprint, one, and a ban on lead-related products by many safety agencies? How do those are two different questions there. The carbon.
I'll take them one by one. We might as well address the ban, because a lot of people talk about lead batteries and they seem to think there may be a ban in the future. Certainly in Europe, there's a piece of legislation both under REACH and End of Life Vehicle Directive looking at restricting the use of lead batteries. The End of Life Vehicle Directive is focused on automotive applications of lead batteries, but we've been granted an extension for that. There's no ban in Europe. The next time that is going to be reviewed is in 2025. But working with the car companies, we've demonstrated why there is no technical alternative to lead batteries. And so there's no restrictions. In the US, there have been work by DTSC in California, but again, they've decided not to restrict lead batteries. They've understood the essential nature of lead batteries. And our industry is aware of the viewpoint of lead. And one of the things that we're putting in place is a material stewardship. We're making sure that lead batteries are produced, collected, and recycled in a very responsible and safe manner. But there's no current ban for lead batteries. In terms of the carbon footprint, one of the real benefits of lead batteries is its very high end-of-life recycling rate. In Europe and North America, about 99% of lead batteries are collected and recycled at end of life, which obviously has a big impact on its life cycle footprint, its carbon footprint. And we actually see that when you take lead batteries and you compare them with other technologies, certainly in manufacture, lead batteries have a much lower environmental footprint, somewhere in the region of 4 to 5 times lower. It can depend on how you use the battery, but generally lead batteries have a very good carbon footprint, and certainly either lower or on the same level as other technologies such as lithium-ion.
Excellent. You anticipated one of my questions, and that was about the recyclability, because that's an important factor. I'm not an expert in carbon footprint calculations, but my understanding is I think we need to look at how the carbon footprint is being calculated over the life of these products, because people are making important business decisions based on that. And if we talk about nanomaterials like carbon, if you look at the gains that you get in performance versus the cost of production, I think you really have to look at that whole life cycle. I don't know if you have an opinion about them.
Yeah, I mean, yes, absolutely. And that's one of the things that we do a lot of work on, is looking at the life cycle associated with carbon footprint. We do a lot of life cycle assessment. With the lead batteries, not only are they collected and recycled at such a high proportion, the other thing is that virtually all the components of a lead battery are recyclable. So every single bit, the lead compounds, the plastic, all recycled. And one of the things that when we add carbon, we need to make sure that carbon is also recycled, because one of the real benefits of lead batteries is their very high end of life recycling. So that's some of the things that we try and do in terms of our research. But it is a very important aspect to lead batteries. And one of the things that we're promoting is it should be used as a blueprint for other technologies, because certainly other technologies do not have such a high recycling rate, and certainly a lot of their batteries are not made up of as much recycled material. So a typical lead battery on the market is made up of 85% recycled material, which is a lot higher than the majority of consumer products.
That's an important point. That's excellent. One of the other questions that's come up is the use of carbon. Obviously, as the Graphene Council, we're highly interested in this topic. And so one of the questions from a participant: what are the most important carbon properties to improve the battery performance, and how do you measure them? And then I would just add to that, you mentioned briefly carbon nanotubes. We deal with graphene. Graphene itself is not one material, but a whole family of these sp2 bonded carbon materials. How do you respond to that? What kind of carbon do you find? And obviously, I'd love to hear, where does graphene fit in your opinion?
So we can start. I can start with graphene. And actually, graphene is a. So we've been looking at carbon black, carbon nanotubes. Graphene is something that is newer in our research program. We have funded some work with a large battery company in China, looking at how you can use carbon graphene to improve lead batteries, specifically for e-bikes. And this is certainly a very new area for research, but the data that's coming out is actually showing that you get very much improved performance using graphene. And I think our membership is likely to do a lot more research. I say that graphene is very much it's the beginning of our research. We've been looking at the other technologies for a lot longer, but graphene is new. And one of the other things I would say is, and I think it highlights the potential to improve lead batteries further, is that we've been using different types of carbon. We understand that they improve performance, but we don't fully understand the mechanism of why carbon improves lead batteries. There are 3 different postulated mechanisms for why they improve the performance. And so we're doing a lot of work at the moment to actually understand why. And I think when we get that answer, it will help us really make sure we can maximize the performance of lead batteries.
Can you expand a little bit on, where in the battery, in the lead battery, the carbon is being used, and do you have any kind of metrics on an amount or a ratio of carbon that's being used as part of the construction?
Yeah, so it can be used it's been studied using in a range of different areas. So it's been shown to use in the electrodes, in the active mass. There are new companies who have been developing specific like grid meshes where it's been used. It's been used in the majority of areas. I apologize that I'm not so technical. I can't tell the exact amount of how much we use carbon in those applications. But if you have questions, I can put you in touch with my technical team who can talk about it. It's normally in a reasonably small amount. It's not a huge amount of carbon. It's normally added in a few percent to tailor to the electrode, etc. It's not a huge amount. But if you think about the number of batteries on the road, in every vehicle on the road, it's quite a lot of carbon at the end of the day.
True. Well, we're used to that with graphene. A very small amount of it goes a long way, but that's just fine. We as long as it's used. We have just a few more minutes for a couple more calls. One of the questions is, we hear a lot about the supply chain issues, lithium, magnesium, cobalt for lithium-ion batteries, et cetera, which again, as everybody races towards that technology, is going to put pressure on supply chains, I think. What does that look like for your sector?
Sorry, Terence, I missed that. Could you just repeat the question?
Yeah, with everybody pursuing lithium ion, and you have some limited materials like lithium, cobalt, magnesium, et cetera.
Oh yeah, I got it. I've got
Okay.
it. So actually, supply chain issues is something that is really our strength. So in Europe and North America, as I say, virtually all the batteries are collected and recycled. All that material is then used to manufacture new batteries. We don't have any materials in our batteries that are difficult to source. We are quite a simple technology. So in terms of Europe and North America, the majority of batteries that are manufactured can be sourced from material that is produced in Europe or North America. So supply chain issues is actually one of our strengths. We are almost the perfect example of a closed loop technology where you can collect, recycle, manufacture all in the same area. So it avoids a lot of those issues that you see in other battery technology.
Understood.
Maybe I could just grab on the question about Tesla, the auxiliary battery, because I know a lot of people talk about that. There's certainly been a lot of fanfare that Tesla is going to replace its lead auxiliary batteries. We do a lot of work with car companies. In general, the majority of them are very focused on safety. And lead batteries have been used for such a long time. The safety profile is very well understood. And generally, it's a lot safer if you can have two different technologies in a car. So you'd have the big lithium battery, the propulsion battery, and then you'd have a smaller lead battery, safety auxiliary battery. And so the car companies are very much in favor of having two technologies. So there may be one or two car manufacturing, Tesla, for example, who will install a lithium-ion auxiliary battery. But to do that, they need to install a lot more safety features, which is obviously costly and has safe space considerations. So generally, we still expect lead auxiliary batteries to be the dominant battery in that market in the future.
Excellent. Well, Alistair, I think we're going to have to end it there as we come to the end of this, but I also want to reach out and say, I think there's a lot of opportunity for the companies in the Graphene Council that produce graphene materials that are maybe not looking at lead acid until today. Yeah. And obviously from your side, I think we can help you and your group better understand the differences of the forms of graphene, supply chain issues with graphenes for reliable suppliers, et cetera. So I hope that we will definitely...
I mean, one of the things is actually we're about to start funding for new projects, and we'll be making a song and dance. So if companies are interested in putting in projects for funding with different types of carbon, we'd be very interested in considering those proposals. So I would encourage those companies to do so, and I think there's a lot of collaboration that can be done with you guys, because we see carbon and graphene as a very important part of the future of lead batteries.
Fantastic. Thank you so much, Alistair. And people have asked for your contact details. I'll just repeat, everything's being recorded. Copies of the slides will be presented, so you can contact Alistair directly. And we encourage you to get in touch. Alistair, thank you so much. We really appreciate your participation and your contribution. So thank you.
Great. Thanks very much, Terence. All right. Cheers.
Cheers. Have a good day.